The groundbreaking discovery that led to the transistor came in December 1947 at Bell Lab. A team consisting of John Bardeen, Walter Brattain, and William Shockley were studying the properties of semiconductors with the aim of replacing vacuum tubes. Their collective efforts culminated in the creation of the first point contact transistor. In essence, they managed to harness the properties of semiconductors to regulate current flow, paving the way for amplification and switching functions in a fraction of the space previously required by vacuum tubes. In this episode, we're going to do an overview of the history of the 2N2222A NPN bipolar junction transistor. But first, let me take a moment and talk about Cyber City Circuits. I'll make it quick. Cyber City Circuits was established in 2018 in Augusta, Georgia. We offer an assortment of services including low to medium volume PCB assembly, PCB design, prototyping, QC testing, and more. If you'd like to support the show, please keep us in mind next time you find that you have PCB design and assembly needs. Now back to the show. In recognition of their monumental contribution to society, Bardeen, Brattain, and Shockley were awarded the Nobel Prize in Physics in 1957. There is some drama associated with this teaming, and if you'd like to hear that story sometime, let me know in the comments or send me a message on X. One of the inventors of the transistor, John Bardeen, donated the first transistor ever built to the Spurlock Museum at the University of Illinois, where it resides today. It is said that it was Bill Shockley that further advanced the design by introducing the bipolar junction transistor in 1948, a more stable and manufacturable version of the initial invention. How does a transistor work? A transistor controls current flow between the collector and the emitter, controlled by the base voltage. In an NPN transistor, applying voltage to the base allows electrons to flow from the emitter to the collector. It acts as a switch or amplifier, depending on its configuration. The 2N2222A is an NPN transistor. It is essentially a semiconductor sandwich, where the N layers are the bread and the P layer is the innards. The emitter is packed with electrons trying to get from the emitter to the collector, but the base blocks the flow with the P layer. When a voltage is applied to the base, the N material gets pulled back like a curtain, and then we have current flow. The 2N2222 bipolar junction transistor is the most successful and prolific discrete transistor ever produced. It is an NPN switching transistor designed by Jack Heineken at Motorola in 1962. A comprehensive oral history of Jack Heineken is available at the Transistor Museum website by Jack Ward. If you would like to learn more, a link to this site can be found in the show notes. John Jack Heineken was born in 1935. Jack Heineken joined Motorola's semiconductor division in 1959, and he developed some of the very first silicon-based transistors. Jack Heineken's major contribution to the development of silicon transistors is the angular process and star geometry. In this description, I'm going to use terms like source, drain, and gate because that's how the documentation that I'm referencing describes it. But just know that collector, emitter, and base are the same in many ways. An angular design has the drain in the center with the gate surrounding it and the source on the other side. Prior to this, they were more of a sandwich with the gate in the middle of the two other layers, but this innovation allowed for faster switching and much higher power efficiency. It's a pretty big deal. The star geometry was the breakthrough that the world needed at the time. This created more surface area overlap between the layers, allowing for significantly more current flow. This was the magic trick that made the 2N2222 so revolutionary. The transistor star architecture was impactful to transistor design because it allowed for a more compact design, faster switching frequencies, higher reliability, longer lifespan, and higher efficiency. The modern 2N2222A transistors use a more advanced geometry for even more surface area overlap, allowing for more efficiency, higher current flow, and higher reliability. In August 1962, Jack Heineken published his invention named the semiconductor device with Motorola by filing patent 3226611. In the patent, the annular ring process and its manufacturing is described in painful detail. Jack Heineken would continue a career with Motorola, becoming the vice president of operations in the semiconductors division in 1969 at the age of 34, 10 years after starting at Motorola. He later retired from Motorola in 1975. The 2N2222A is a prolific NPN bipolar junction transistor that quickly became one of the most important components in the world. While you can find a 2N2222 transistor in many different packages from many different manufacturers, traditionally, the part number 2N2222A is referring to the TO18 CAN package. With the 2N2222A's characteristic, it serves as a linchpin in many electronic devices, including radios, televisions, and computers throughout its 60-year life. Furthermore, its switching frequency allows for it to operate efficiently in radio applications. These technical specifications, backed by its reliable performance, have made it a go-to transistor for hobbyists, students, and professionals. The specification for this transistor is named 2N2222 in accordance with the JEDEC EIA 370. The EIA 370 is freely available from JEDEC through a free membership at jedec.org. According to the EIA 370, the designation 2N2222 consists of three different sets of information. The first two is the number of useful connections minus 1. It's a transistor with three useful connections, so the first number is a 2. This makes sense because parts that start with a 1N, like the 1N4001, are all diodes. The N means that it is a registered package part specification. Alternatively, the letter C could be used there to signify an unencapsulated chip. The 2C2222 is essentially the die chip that would go into the transistor. So if you take any 2N2222A transistor off the shelf, it would have a 2C2222A inside of it. The difference is the package. That's pretty neat. The 2222 is the second set of numbers and is assigned consecutively when the device is registered with JEDEC. So apparently the most prolific and important transistor in history is named 2222 out of pure luck. Over the years, I thought the 2222 had some significance, but that is not the case. The EIA 370 says that the set of numbers shall consist of two or more digits assigned consecutively, starting with the number 21. So this means I should be able to find a part designated 2N21, right? Through the Transistor Museum, I was able to find the 2N23 point contact transistor developed in 1952. This was developed by Bell Labs with Western Electric and was the most common germanium transistor used during this time. It was used for research that led to the proliferation of transistors in the 1960s. So I start thinking to myself, the EIA 370 was published in 1982, and the 2N23 was developed in 1952, and the 2N2222 was released in 1962. It clearly wasn't following the EIA 370 with this nomenclature then, right? On the Transistor Museum website, it explains that Western Electric wanted to standardize their identification and used the RTMA standard to apply 2N to proprietary types. Keep in mind that these are the earliest of usable transistors. By 1956, all germanium bead-style transistors were obsolete and no longer needed. The organization RTMA is referring to the Radio Television Manufacturers Association. In 1957, the RTMA changed their name to the Electronics Industry Alliance, or better known today as the EIA. When the name and numbering system was developed, it was intended for vacuum tube devices, but they didn't know how else to identify new transistor devices. That's pretty neat. When I was doing research for this episode, the JANS version of the microchip 2N2222A was in stock and has the distinction of being the most expensive 2N2222 BJT available on DigiKey with a listed price of $32.81. Weighing in at 0.261 grams, the microchip JANS 2N2222A transistor selling for $32.81 on DigiKey is literally worth twice its weight in gold. It costs so much because it is the JANS variant. JANS is spelled JANS. The JAN stands for Joint Army Navy, and the S stands for Space Grade. And it means it is a military part made to MIL S 19500 specifications, with the die visually checked during production and tested to spec after production. This transistor was manufactured specifically to be able to go into space, so that's pretty cool. It comes in a TO18 through-hole package and is visually identical to the dozens of others produced by other manufacturers. But the difference here is, because it is JANS, it is the closest you can get to a guaranteed perfect 2N2222A. In applications like sending a rover to Mars, I imagine things like this matter. The importance of the 2N2222A to civilization cannot be understated. Serving as a fundamental building block in electronics, it was pivotal in modern electronics. This humble transistor has indirectly shaped communication, entertainment, and technology for the past 60 years. All right, everyone, that's it for tonight. Thanks for coming. If you'd like to support the show, please leave a written review on Spotify or Apple Podcasts. You can follow the show on X at Datasheet Digest and follow Cyber City Circuits on X at Make Augusta. Please have a great rest of your day.